Hello friends, this is Road to IIT and today we are going to solve some past year JEE problems. Okay, so the JEE mains 2017 is very near, so we are not going to start any new thing. We are just going to solve some past year JEE problems. Okay, so without wasting our time, let's get started. This question is asked in JEE Advanced 2014, a very good question. So what we have here, let f be the function from a to b, a comma b to 1 comma infinite be a continuous function, and let g is function from r to r defined as g of x is equal to 0 if x less than a, integration of a to x f of t dt if a less than or equal to x less than or equal to b, and a to b f of t dt if x greater than b. Now we have there four options to check whether g of x is continuous but not differentiable at a, is differentiable or r continuous. Okay, so we have to check the continuity and differentiability at both the 2 points a and b where it is separated. Now without wasting our time, let's get started. First of all, continuity. For continuous, we know that the limit x tends to a minus is equals to limit x tends to a plus, must be same. Here limit x tends to a minus, it is 0. Okay, now limit x tends to a plus. Okay, so here it must continuous at x is equals to a or x is equals to b to continuity checking. Now x tends to a minus g of x, that means x less than a, it is 0 already given. Now x tends to a plus g of x, a plus g of x, that means my function is this a to x f of t dt. Okay, a to x f of t dt is equals to, now if I put the upper limit here, that is a to a, if the upper and lower limits are same, the integration is 0, so it is equals to 0. Okay, that means this and this value are same, that is equals to, and we also have to check at that particular point. Now here you can see the a less than or equal to x, that means for x is equals to a, this is also a function value, so that means it is also 0, that is mentioned here. G of a integration a to a f of t dt is equal to 0, that means this and this all are same, that means limit x tends to a g of x, a minus g of x, a plus g of x, and g of a, three are same and is equal to 0, that means the function is continuous at x is equals to a. And similarly you can check this thing for b also. See, for x less than b, the same function is applied. Okay, for g of b, this function is applied, and if you are going to check for x greater than b, then this function is applied, a to b f of t dt. Here if you put b, then a to b f of t dt, then that means all the three of are going to be same, that means it is also continuous at x is equals to r, that means the function is continuous at x is equals to a and b both. Okay, now we have to check for the differentiability. Now g dash of x, now see here it is 0, so its differentiation is also 0. Now the differentiation of this part, and for that you must have to know the Leibniz rule. At that time in the topic video of Leibniz rule, I posted a video on that almost 1 week ago, and I told you at that time that it is a very helpful thing. Now for those students who don't know that, please go to that video. So what is Leibniz rule? Upper limit into the function into the differentiation of upper limit minus lower limit into the function into differentiation of lower limit. Now here upper limit into the function, that is f of x, and the differentiation of upper limit, that is x, the x is differentiation, that is 1, so f of x into 1 minus a into f of a into differentiation of a, that is 0, so it becomes f of x into 1. So here you can see f of x here. That's why this is an important thing to know the Leibniz rule. Okay, and similarly here a to b f of t dt, here you can see both the limits are constant, a to b, no variable, that means the answer is 0 because the differentiation of limit is 0 for the upper and lower both. So you can see here it is 0. Now as we know differentiability rule, g dash of minus a minus, that is 0, g dash of a plus, that is f of a. Again, g dash of b minus, that is f of b. Again, g dash of b plus, that is 0. So these are not same. That means hence it is non-derivative at x is equals to a and x is equals to b. That means they both are continuous at a equal a and b, but not differentiable at a and b. Okay, so a very good question from JEE Advanced 2014. Okay, so let's see another one. This is also from JEE Advanced 2014. This is from the matrix chapter. Still a easy but tricky question. Let M be a 2 cross 2 symmetric matrix. First of all, what is symmetric matrix? Symmetric matrix, that means A is equals to A transpose. So here you can see M be the symmetric matrix. Then M is invertible. That means the inverse is exist of M, and we have to check for this for condition. This is a multiple choice question, so more than one question's answer can be possible. First of all, we have to take an assumption for M. M is 2 cross 2 matrix and it is symmetric. So let's say M is equals to AB BC. Why I am doing this? Because if you transpose this, if you take a transpose, M transpose, it is also AB BC. That means M is equals to M transpose and it is symmetric matrix. So this is a general assumption for symmetric matrix. The value in the second diagonal must be same for that. Okay. Now, what is first option? In first option, they say that the first column of M is the transpose of second row of M. That means first column of M is the transpose of second row of M. That means this two are second row is this. That means this two are transpose. If this two are transpose, then this is the second row BC, and it's transpose. That means the column BC row is going to be transferred in the column if we take the transpose. Now if we equate this, A is equals to B and B is equals to C. That means A is equals to B is equals to C, and if all the entries are same, then the mode of this is equals to 0 and it is not invertible, because the formula of M inverse is equals to 1 upon mod A adjoint of A, and the condition is mod A must not equals to 0. Here mod A is, becomes 0 and it is wrong, so A is wrong. Now we have to check for B, C and D. Now in B, what they say, the second row of M is the transpose of first column of M. Now the second row, what is second row? Second row, that is BC, is the transpose for first column. First column is AB and it's transpose. That means again B is equals to A and C is equals to B. So again B is wrong, because all entries are same. The mod M becomes 0 and inverse is not exist. Now third option, M is a diagonal matrix with non-zero entries in the main diagonal. Okay, that means main diagonal has the non-zero entries and this two have 0. That means we have the value of mod M, that is AC, and it is say that it's non-zero. That means it has some values, and that means C is correct, because if mod M is not equal to 0, then inverse must be exist. That means C is my right option. We have to check for D because it's multiple choice. The product of entries in the main diagonal of M is not the square of an integer. That means the A, B, B, C, it is given that the product of entries in main diagonal, that means AC, is not equals to the square of any value, because here you can see that B into B, that is B square. That means this is going to be square of something. If AC is equal to square of something, then there is a chance of that this matrix can have 0 value. But it is said that it is not equals to value of something lambda square. That means it must not be 0 and inverse is going to be exist. So C and D both are correct option. Okay, easy question but still a tricky question. Let's see one more example. Okay, there is also a multiple choice question, a very good question. Contain the application of derivative, contain the function, contain the Leibniz rule, contains the even odd, everything. F is the function from 0 to infinite to R, given by f of x is equals to 1 by x to x e raised to minus t1 plus 1 by t1 dt upon t. Now we have to check for this 4 options. So see, first option they said it is monotonically increasing on 1 to infinite. So for increasing decreasing we have to go for the first derivative. Now see, this is my function f of x is equals to 1 by x 2x e raised to minus t plus 1 by t dt by t. Okay, now again the Leibniz rule are applied here. At that time I told you that it is a very important rule. So what we have to do, the derivative of upper limit, that is 1 into upper limit into the function, that means e raised to minus x plus 1 by x upon x here, minus differentiation of lower limit, that is 1 by x, its differentiation is minus 1 by x square, minus minus gets plus here, and you have 1 upon x square. This is the differentiation of lower limit. Now the lower limit into the function, that means e raised to minus x, here it becomes 1 by x, here it becomes x, and here 1 upon 1 by x, that is x over here. Okay, now this x and this square x that gets cancelled out, and we'll have x in common denominator, so we have the 2 e raised to minus x plus 1 by x upon x. Now as you see that this function is always increasing in 1 to infinite. Why? Because it is exponential. In exponential it is always the value must be greater than 0, 2 is greater than 0, and x, they say that it is from 1 to infinite. It is 1 to infinite. That means this is always a greater than 0. That means the function is monotonically increasing in 1 to infinite. Okay, so option number A is the correct option. A is correct option because f dash of x is greater than 0. That means A is correct. That means B is obviously wrong. Why? Because B says that it is monotonically decreasing on 0 to 1. Okay, that means it must be wrong for that part. Now, and if you don't believe that, you can check for that particular region also. Okay, now again C, in the C option they say that f of x plus f of 1 by x is equals to 0. So we have to add f of x plus f of 1 by x. So let's do that. F of x plus f of 1 by x, that means 1 2x x e raised to minus t plus 1 by t dt upon t plus x to 1 by x, because here if we put 1 by x, then 1 upon 1 by x, that is x. Here it becomes 1 by x e raised to minus t up plus 1 by t upon t dt. Now let's take an assumption t is equals to 1 by p. If you take an assumption t is equals to 1 by p, the limits is changed. Here it becomes 1 by p, here it becomes p, here it becomes e raised to minus p plus 1 by p, and dt equals to minus 1 upon p square, and again pp gets cancelled out, and we left with this minus of 1 by x to x e raised to minus p plus 1 by p dp by p. Here it is p, here it is p, because we take an assumption t is equals to, sorry, it's correct. Here it is 1 by x to x because the limit is changed. T is equals to, here if we put x, then p equals to 1 by x. This is correct. Now this is in the form of dp as a variable, this is in the form of t as a variable. Now in the integration, the limit, the variable can be changed if the value is same. So p here can be written as t without wasting a time. So here you can say this is all the p as a t because the value is same, and this both are gets cancelled out, and we have 0 as an answer. So C is also correct option. Now we have to check for D also. They say that f of 2 raised to x is an odd function of x on R. Now as we know that f of x is equals to minus f of 1 by x, because f of x plus f of 1 by x is equals to 0. That means f of x plus f of minus 1 by x is equals to 0. So f of x is equals to minus f of 1 by x. Now f of 2 raised to x is equals to minus of f of 1 upon 2 raised to x. That means f of 2 raised to x is equals to minus of f of 2 raised to minus x. That means you can see that this is the sign of odd function. This is a sign of odd function. That means D is also a correct option. The function is odd if you put x is equals to minus 1 by x and you have the minus sign there, that means it is an odd function, so it is also a correct option. That means D is also correct. That means A, C and D both are, each and three options are correct. So a very good question asked in JEE 2014. Keep solving. If you have any doubt, ask me in comments. For revision is the most important thing. Watch all the previous video, that is going to help you a lot. Thank you for watching this video. If you like this video, don't forget to share it and hit that subscribe button. Thank you.